Let's look at some examples of computing the exact values of some trig functions at some of our special angles. Okay, we've already looked at computing the sine and the cosine values in the first quadrant, and then we've also looked at computing the sines and cosine values anywhere on the unit circle, so not just the first quadrant, but anywhere on the unit circle. And then we've also looked at some identities. So we've looked at the fundamental identities, which includes the Pythagorean identity, the reciprocal identity, and then the even and odd identities. And so we're going to use those identities to simplify how we can compute our secant and cosecant and cotangent values, or tangent as well for that matter. Okay, so let's just take a look at a few examples here. And what I've also included, again, we've seen this before, but I have the first quadrant of our unit circle for the 0, 30, 45, 60, and 90-degree angles along with their corresponding terminal coordinates. Okay, so let's start off with the secant of 5 pi over 6. So what I will start doing, again like I did before, is we just want to locate where 5 pi over 6 is at on the unit circle. Okay, we need to figure out what quadrant it's in. So we'll just draw kind of a little circle here and locate ourselves on the circle. We know that 0 is the positive x-axis and pi is the negative x-axis, right? So 0 to pi is half the circle, and if we kept going, we'd get to 2 pi if we did the full circle. Okay, so pi, again, is the same thing as 6 pi over 6 if we used a denominator that matched our 5 pi over 6. So we need to divide the top half of the unit circle into 6 equal parts. So 1, 2, 3, 4, 5, 6. And we don't need to go further because we're only going to go to 5. So 5 pi over 6 is in the second quadrant, and it's just above the x-axis. And if we look at its reference angle, our reference angle or reference number would just be pi over 6. Okay. The next thing we need to think about is, where are our functions positive? What are the signs of our functions in each of the quadrants? Okay. So we looked at this last time. We know all of the functions are positive in the first quadrant, all 6 of them. Okay. In the second quadrant, sine was positive, which, remember, sine goes with cosecant. So if we're dealing with cosecant, it would also be positive in the second quadrant because both sine and cosecant relate to the y coordinate. Tangent is positive in the third, and again, tangent would also represent cotangent. And then cosine is positive in the fourth quadrant, and cosine is paired together with secant. So in this case, we have secant. Secant is positive in the first and the fourth quadrants, and so in the second quadrant, which is where 5 pi over 6 is located, we know we're going to have a negative angle. Okay, and we know that our reference angle is pi over 6. So we have almost all the parts here. The only other thing that we need to think about is, how is secant related to sine, cosine, or tangent? Okay, and so let's go ahead and use one of those identities that we just came up with. We have, one of our reciprocal identities that tells us that secant of theta is equal to 1 over cosine of theta. So secant and cosine are reciprocals of each other. So if I'm trying to compute the secant of 5 pi over 6, that means I can really compute 1 over the cosine of 5 pi over 6. Okay, and so from there on out, it's just stuff we've already been doing. We know cosine of 5 pi over 6 has to be the same as cosine of its reference angle. So cosine of 5 pi over 6 has to have the same value of just cosine of pi over 6. The only thing we have to worry about is whether it's a positive or negative value. We already talked about that. Secant, just like cosine, is only positive in the first and the fourth, which means it's negative here in the second quadrant. So I now have 1 over the negative cosine of pi over 6. To figure out the cosine of pi over 6, we just need to look at the first quadrant of our unit circle. So pi over 6 is corresponding to our 30-degree angle, and cosine is the x-coordinate. So cosine is going to be a square root of 3 over 2. So if we plug that in for cosine, we have 1 over a negative square root of 3 over 2. And all that's really left from here is just to simplify that. So if we take a 1 and we divide it by a fraction, we can just flip the fraction around, right? You multiply by the reciprocal. So it turns out that the secant of 5 pi over 6 is equal to a negative 2 over the square root of 3. Okay, so let's try the second one. This time we want to do cosecant of a negative 7 pi over 4. Okay, so the things we need to think about here: where is negative 7 pi over 4 located? What's its reference angle? Which of the three main trig functions, or which of the two, is cosecant connected to sine or cosine? And then what is the sign, positive or negative, in the quadrant that we're in? So those are kind of the pieces that we need to pull together here. Okay, so let's again start with drawing a graph, figuring out where this angle is located. Okay, so again, we'll just draw our unit circle. And we're talking about 7 pi over 4, so we need to divide our circle, divide the top half into fourths and the bottom half into fourths. So we got 1, 2, 3, 4, 5, 6, 7, and 8. So there's our quarters. Okay, so 7 pi over 4. I'm sorry, negative 7 pi over 4. The negative means that we are going to be rotating in the counterclockwise direction. Sorry, not counterclockwise. We're going to be rotating in the clockwise direction. Okay, so if I start here at the x-axis, we're going to rotate down into the fourth quadrant, and that'll be negative pi over 4, and then negative 2, negative 3, and then we'll get to negative 4 pi over 4 at the negative x-axis. Keep going. Negative 5, negative 6, and negative 7. So negative 7 pi over 4 is a point, corresponds to a point in the first quadrant. Okay, and the nice thing here is we know that all the functions are positive in the first quadrant. The reference angle for 7 pi over 4 would just be pi over 4. Because that's how far it is from negative 7 pi over 4 to the x-axis. It's just pi over 4. Okay. So that means, and again, there's different ways we could piece all this together. The other thing that we want to look at is finding our relationship between cosecant and either sine or cosine. Well, I know that cosecant of theta is equal to 1 over sine. So cosecant and sine are reciprocals of each other. So I could rewrite cosecant of a negative 7 pi over 4 as 1 over the sine of a negative 7 pi over 4. Now, we also know that negative 7 pi over 4 has a reference angle of just pi over 4. So this becomes 1 over the sine of just pi over 4. But again, now is where we apply the sign. Is this sine of pi over 4 going to be positive or negative? And we already talked about, because negative 7 pi over 4 is in the first quadrant, it has to be positive. Okay, so we have 1 over the positive sine of pi over 4. And so now we can compute what the sine of pi over 4 would be. So to do that, we need to find pi over 4 in the first quadrant, which is your 45-degree angle. And the sine is always the y-coordinate. So we're going to get 1 over the square root of 2 over 2. And again, that's positive. And since it's a reciprocal, it's a fraction, 1 over a fraction, we can flip the fraction. So the cosecant of a negative 7 pi over 4 is equal to 2 over a square root of 2. If you wanted to, we could leave it there, and that's generally fine with me. But we could rationalize this a step further. We could have done that with the first one too. But if we multiply top and bottom, so numerator and denominator, by square root of 2 over 2, it turns out that this is 2 root 2 over 2, or just a square root of 2. Okay, so the cosecant of negative 7 pi over 4 could be expressed as 2 over the square root of 2, or you could simplify down to just writing it as a square root of 2. Okay. All right, let's do one more here. We have the tangent of 5 pi over 3. So we're going to, again, follow the same process. We want to figure out where is 5 pi over 3. So if we draw our circle, we're dividing everything into thirds. So 1, 2, 3, 4, 5, and 6. Okay, so we're dividing the top half and the bottom half into thirds. And then we're just going to count around. This time it's positive, so we're going to go back to a counterclockwise direction. So we have 1 pi over 3, 2, 3 pi over 3 is the x-axis again, and then 4, and then 5 pi over 3. So we're down here in the fourth quadrant again at 5 pi over 3. We also know that the reference angle to the x-axis is going to be pi over 3. Okay, so how do I connect? We could just go ahead and jump straight to what the tangent value would be, but let's use some of our properties here to connect tangent with our sine and our cosine values. Specifically, we know that tangent, the tangent of theta is equal to the sine of theta over the cosine of theta. Okay. I like using this because I don't need to memorize what tangent is anymore. I can just remember what sine and cosine are. So it kind of reduces the things you got to memorize. So I could rewrite the tangent of 5 pi over 3 as the sine of 5 pi over 3 divided by the cosine of 5 pi over 3. Okay. So now let's apply our reference angle. Okay. So I could rewrite both the sine and the cosine as pi over 3. So sine of pi over 3 over the cosine of pi over 3. But now I do need to apply the sign, the positive or negative here. What do I know about sine and cosine in the fourth quadrant? Well, again, sine is a y-coordinate, so it's positive in the first and the second. Cosine is an x-coordinate, so it's positive in the first and the fourth. So sine in the fourth quadrant is negative, cosine is positive. So my final answer should be negative, right? If you take a negative divided by a positive, you get a negative, which should make sense because tangent is only positive in the first and the third, which again means it's negative in the fourth. Okay, so let's go ahead and finish this up. What is the sine at pi over 3? So to find our pi over 3 angle, which is 60 degrees, sine is the y-coordinate. So we have a negative square root of 3 over 2 divided by the cosine. So cosine at pi over 3 is the x-coordinate, which is a half. So we have a negative square root of 3 over 2 divided by a positive 1/2. The 2's are going to cancel, and so we're left with just a negative square root of 3. So the tangent of 5 pi over 3 is equal to a negative square root of 3.